Welcome to the Infinite Jungle, the podcast about the evolution of Ethereum. On today's show, we're going to be talking about All Core Developers Execution Call number 187, ACDE 187. The main takeaway from the call was updates to EIP 3074. Developers talked about the new changes to the code change that might be happening. There was a alternative EIP, an alternative code change to EIP 3074 that was proposed, and it was proposed by Vitalik, Buterin, the co-founder of Ethereum, actually on a call a few days before the latest ACDE call. So we're going to talk about how that conversation went down. We're also going to be talking about some of the other more minor updates that was shared on the latest ACDE call. But before we get started on the show, here is a quick show disclaimer. I need to remind you to please refer to the disclaimer linked in the podcast show notes and note that none of the information in this podcast constitutes investment advice, an offer, recommendation, or solicitation by Galaxy Digital or any of its affiliates to buy or sell any securities. All right. So before developers went into all of the conversation about EIP 3074, developers gave a quick update on the Pectra DevNet timeline. We talked about the DevNet, the Pectra DevNet, what it means for the Ethereum upgrade process on last week's show. So if you need a quick refresher on that, go listen to last week's call summary show. But basically, the very first testnet for the next Ethereum upgrade is what developers are working towards right now. And on the latest ACDE call, developers shared that they are aiming to try and launch the first Pectra DevNet on Monday, May 13th. And it sounded like quite a few execution layer client teams were ready with their full implementations for the Pectra upgrade. And it also sounded like the consensus layer client teams, not many of them were ready with full implementations quite yet. That also makes sense because on the last ACDE call, last week's episode, I shared that developers were facing some unexpected complexity with the code changes that they had agreed to implement on the consensus layer of Ethereum. So it sounded like, the consensus layer client teams are still really working through that, which is why not as many of the CL teams shared that they were ready with full implementations quite yet. But overall, it sounded like the testing team of Ethereum, that is the testing team that is housed under the Ethereum Foundation, who is working really closely with these client teams. It sounded like they were pretty confident that they'd be able to launch the first Pectra DevNet with at least one full implementation consensus layer and execution layer client by Monday, and if not Monday, shortly thereafter. So sounds like one more kind of step forward in preparing the next major Ethereum upgrade. And then after talking about those quick highlights to Pectra and the Pectra DevNet, developers went into EIP 3074. So as a quick refresh about EIP 3074, this is a code change that's designed to make user-controlled accounts on Ethereum a lot more flexible and programmable. Right now, Ethereum does not easily support functionalities for user-controlled accounts, which are also called EOAs, externally owned accounts. There are features that many users and wallet developers would like to have, like transaction batching, which means that by signing off on a transaction on Ethereum with your private key, your cryptographic signature that only you can that only you as the owner of that account can create, be able to sign off on multiple transactions with just one signature, especially when you're interacting with decentralized finance applications that require you to authorize trades, authorize liquidations, or authorize the closing of a loan. Anytime you're interacting with finance-focused smart contracts on Ethereum, you have to authorize those transactions one by one. And one of the things that would be really helpful for the user experience is being able to batch together the authorization of multiple transactions with one signature. Another one is sponsorship. Transaction sponsorship. So every time you're sending a transaction on the Ethereum network, you have to pay for it. You have to pay a fee for it, which is a little bit of additional ETH that you attach to that transaction. And for some applications that are maybe trying to bootstrap its launch or trying to encourage more users to use their application, they'd like to be able to sponsor transactions, basically pay for the fee attached to that transaction on behalf of the user. And this could also perhaps one day become a very nice Christmas gift or like some kind of a service that allows other people to pay for another user's transactions. But anyways, these are kind of qualities about EOAs that are just not possible today, which is why EIP 3074 was included in the Pectra upgrade. But on the call 2 weeks ago, I explained that EIP 3074, the inclusion of EIP 3074 in Pectra was pushed back by quite a few of wallet developers and people working on the long-term roadmap to make EOAs programmable, fully programmable, and just be able to have even more features than just the two that I just mentioned. And this initiative to try and make EOAs as programmable as smart contracts, basically convert EOAs into smart contract wallets. That's called account abstraction. And developers representing the AA community, the account abstraction community, and wallet developers shared that they had a lot of concerns about EIP 3074, particularly about the security of EOAs because of this code change. Which is why developers at the time said, let's do a breakout meeting just to talk about the path forward for EIP 3074. So the conversation was time boxed there and developers moved on to other topics on the call. The breakout meeting happened on Tuesday. I believe that was May 7th or May 8th. Basically a few days before the ACDE call, the latest ACDE call happened. And on that breakout meeting, Vitalik shared a new proposal, EIP 7702, that would address a lot of the concerns that were raised about EIP 3074 and still be able to enable transaction batching and transaction sponsorship, and still be able to move the ball forward for more flexible EOAs. And when developers were giving an update on that breakout meeting on the latest ACDE call, the Geth developer, who goes by the pseudonym Light Client, he said that the sentiment on that call for EIP 7702 was quite positive, and that many people on the call were in support of this alternative to EIP 3074. And I think the biggest difference is that EIP 3074 creates two new opcodes on Ethereum, two new operations that can be called on Ethereum through a transaction. But EIP 7702, which is the one that Vitalik had recently proposed, it bypasses the need to create any new opcodes, any new operations on Ethereum. It simply creates a new transaction type that would enable this kind of programmability and flexibility for Ethereum accounts, for Ethereum EOAs, for the duration of a single transaction. So it's a pretty ephemeral quality about your account. The EOA is not always able to maintain the ability to, sign off on batch transactions and sponsor and have transactions sponsored by another user. But it is a new transaction type that users can opt into and be able to gain the benefits of a bit more flexibility just for the duration of a single transaction on Ethereum. So there's quite a bit of questions still to be answered about EIP 7702. I think the two biggest questions are the cost effectiveness of EIP 7702. So when users are opting into this new transaction type to be able to batch transactions, to be able to have their transactions sponsored, does it significantly cost more fees? Is it significantly more costly than a regular transaction on Ethereum? And how do we ensure that those costs scale depending on the type of activity that a user is interacting with, depending on the type of smart contract that that EOA wants to interact with. So that's a big question. And then another question that developers had raised as a concern about EIP 7702 that still needs to be worked out, whether or not these kinds of transactions, the new type of transaction that a user authorizes, can be revoked after the transaction is submitted. One of the concerns, of course, is that a user doesn't quite fully understand that they are signing off on a transaction that allows them to approve multiple transactions at once. And in that case, can the user, after the fact, realize that this is a authorization that they didn't intend to do, and maybe it was a malicious hacker that was kind of duping them into creating these authorizations that shouldn't have been created? Is there a way to revoke these types of transactions under EIP 7702? So revocability and the gas efficiency. Gas is the way that fees are calculated on Ethereum. It's a unit of measurement for the computational effort required to execute your transactions. So the gas efficiency really refers to how costly that transaction is and the pricing for that transaction in terms of ETH. So those are two kind of big questions that developers still need to figure out before it is officially going to be going into the Pectra upgrade and replacing EIP 3074. For now, developers are going to continue to build EIP 3074, especially for the first DevNet, the first testnet, seeing all of the interactions with all of the code changes that have been included in Pectra. But possibly by the time that developers are ready to launch the second DevNet for Pectra, Pectra DevNet 1, developers may decide to swap out EIP 3074 with EIP 7702. That is still up in the air and is very dependent on the details for EIP 7702 that are worked out in the next couple of weeks. So quite a few exciting updates there and changes about what really is or is not going to be included in the Pectra upgrade. A few other quick notes that I want to share about what was talked about in the latest ACDE call before I get into some insights is 3 other code changes that developers talked about that are not officially included in Pectra, but are being considered, I should say, for the upgrade still. The first one was the SSZ-ification of the execution layer serialization format. Right now, there is a data serialization format that is used on the execution layer that is different from the data serialization format that's used on the consensus layer. And the consensus layer uses SSZ, while the execution layer right now is continuing to use, I think it's RLP, and Merkel Patricia tries, and I don't know what the full spelling, the acronym of RLP stands for, but I'm sure you can find it on Google. So developers for quite some time, ever since basically the merge happened where the consensus layer and the execution layer were merged together and Ethereum became a proof-of-stake consensus protocol, developers have been trying to update the data serialization format of the execution layer to be more compatible and to be in line with what the consensus layer uses. And this is quite an important upgrade for the interoperability between the two layers. And developers basically said on the latest ACDE call that it's not likely that the SSE transition is going to happen in Pectra because it is quite a large lift on the part of execution layer client teams. There were, of course, developers that were pushing back on this decision because of the fact that in Pectra, there is the creation of new data structures that will be using the old format of RLP and MPT. And in the case of creating these new data formats that rely on this old serialization format, this means that down the line, if developers do want to upgrade to SSE eventually, that's more work on them to have to upgrade ever expanding set of data formats and this ever expanding set of code that will need to be updated to SSE. So it was much to the chagrin of certain developers on the call. I think one developer in the Zoom chat even called it a crazy, like quote unquote crazy decision not to include SSE in the Pectra upgrade. But it does sound like developers are quite adamant that it sounded like from execution layer client teams, at least, there wasn't quite an appetite to take on the SSE transition on top of all the other code changes that are being implemented on Ethereum. The next in the running EIP, I'd say, or a bundle of EIPs that are still in the running for Pectra, developers gave Dan O'Farron, who we've had on the show before, independent Ethereum protocol developer, he shared an update on the status of EOF, which is a bundle of code changes trying to upgrade the execution engine of Ethereum, the EVM. He gave an update on what was happening, on some progress made to the implementation of EOF and its specifications. However, developers didn't make a formal decision as of yet on EOF. It's still TBD status. The third code change that developers talked about was EIP 7623. This EIP is about increasing the cost of call data to reduce the maximum size of Ethereum blocks. And a lot of developers think that if developers increase the cost of call data, they might be able to also increase the blob gas limit. The blob gas limit is basically the limit that dictates how many blobs can be included in an Ethereum block. And as a refresher, blobs are binarily large objects, I think, binary large objects. But they're basically space where arbitrary data can be stored, temporarily stored on the Ethereum blockchain. This is a designated space, a designated type of transaction that can be added to Ethereum blocks, particularly designed for Ethereum Layer 2 rollups. Ethereum Layer 2 rollups do not use Ethereum to execute smart contracts primarily, sending over ETH from one account to another. Layer 2s basically are not using Ethereum like a regular user is. Layer 2s primarily rely on Ethereum for data availability, primarily to be able to confirm and finalize batch transaction data from their protocol down to Ethereum, and then to have basically utilize the decentralization of Ethereum, the vast network of computers and nodes that are verifying the Ethereum blockchain, also verify the availability of data submitted by the Layer 2. So it's a quite powerful way to scale Ethereum's ability to process transactions. All of these transactions that are put into blob space by Layer 2s are transactions that are finalized a lot cheaper, a lot faster on Layer 2s, but still are secured, still have the security and the full backing of the decentralized blockchain that is Ethereum. So blobs were introduced in the latest Dencun Ethereum upgrade, and right now I believe the maximum is 6 blobs per block, with a target of a consistency of trying to get at least, or on average, I should say, 3 blobs per block. And developers, of course, want to greatly increase that number of blobs. And one of the ways they can do that in the short term is by increasing the cost of call data. Call data is the space that Layer 2s were using before blobs were available. And by increasing the cost of using that space, they could potentially allow more room and more flexibility for a greater number of blobs on Ethereum. So that's a little bit of the background about EIP 7623. And developers talked a little bit about some of the concerns around EIP 7623, the concern that it may create secondary markets for purchasing call data block space. However, I think developers didn't come quite to a conclusion of whether or not they're going to include EIP 7623 into Pectra or not. They basically said that, look, Pectra is one of the things that needs to happen with EIP 7623 in order for it to be kind of a shoo-in for the upgrade is more analysis and research on exactly how much would developers be comfortable increasing the blob count on Ethereum, the blob gas limit, because of EIP 7623. So by increasing the cost of call data, exactly how much more scalability gains is Ethereum going to be able to get through blobs? And for this question, I think Georgios from the Reth team, who's building the Reth execution layer client, he really kind of pushed developers to have someone assigned to this task of being able to analyze the impacts of 7623 and the analysis on exactly how many more blobs can be added per block. I believe one of the things that Tim Byko, who's the chair of these ACDE calls, he mentioned that Perry from the Ethereum Foundation testing team, the DevOps, developer operations team, mentioned that he might be doing that kind of analysis. So it's still TBD on whether or not EIP 7623 is going into Pectra, but I think developers are really trying to couple that upgrade with an increase to the blob count, and there's still research that really needs to be done to flesh out exactly how much that increase in scalability for L2s would be. So that's a little bit of a summary of the other EIPs that were talked about on the call that have not yet been included in Pectra. One of them clearly does not look like is going to go into the upgrade, SSZ. And then as a final piece of note, a final kind of topic of discussion on the call was around an EIP that developers basically agreed not to include in the upgrade. The EIP proposed a decrease to the cost of two opcodes, two operations, transient storage, T-load and T-store, transient storage on Ethereum for the purposes of helping smart contracts prevent against reentrancy attacks. Reentrancy attacks is basically the type of attack that led to the DAO hack, which was a very infamous exploitation of a smart contract application that happened on Ethereum a couple years after it launched and basically caused a permanent chain split on Ethereum. It caused the creation of Ethereum Classic. The reentrancy attack basically allows a hacker to be able to steal funds from a smart contract by exploiting the fact that the balance of the smart contract is not being updated as funds are leaving the contract. So you can continually drain the smart contract balance because the computation, because the execution of these transactions are not updating the balance of the smart contract to reflect the fact that this user has already taken funds out of this smart contract. And so the idea, or at least the motivation for the original proposal, was to decrease the cost of these two opcodes, which would help smart contracts, rely on these opcodes more to prevent against reentrancy attacks. The argument was that T-load and T-store, these opcodes are just too expensive right now to use by default as a measure to protect against reentrancy attacks, and all of the other options for protecting against reentrancy attacks are just too expensive. So the decrease in cost was not included in Pectra, and the developer who had proposed that EIP proposed a new EIP to address this problem of reentrancy attacks. He proposed the creation of two new additional opcodes that would try and achieve kind of a more cost-effective solution to this problem. And I think developers were not, it was a new proposal, so there wasn't quite a lot of discussion about it. But I don't think there was quite a lot of feedback also given about the prior proposal, the decrease to T-load and T-store costs. And I think it just goes to show that I don't think that developers have quite a big appetite for including anything else in this upgrade. Developers, from my perspective, watching these calls, I think developers are already a little bit overwhelmed with what is going into the Pectra upgrade, and will continue to be extremely wary about including anything else into the upgrade. I think the one code change that does have quite a bit of support from developers, and including last minute, is of course an increase to the blob count, the gas limit. That would be a very simple change. And if coupled with, say, EIP 7623, then maybe it could be done in a way that doesn't negatively impact the networking layer of Ethereum and the decentralization of Ethereum, as increasing blob space, willy-nilly, without really creating ways to make sure that the size of blocks stays within a reasonable range, means that nodes are going to have a lot more of a harder time processing these blocks, propagating these blocks, if they're just so full of data, and quite hard for the networking layer of Ethereum, all the nodes of Ethereum, to be able to support and be able to transmit to other nodes without increasing their bandwidth, without increasing their computational requirements to operate an Ethereum node. So I think coupling those two together will an increase to the blob count, and then the increase to the call data cost. I think coupling those together is still an upgrade that developers really do want to include in Pectra. I think there's a lot of appetite for it, and at least one part of it, which is increasing the blob count, would not be a difficult kind of change to make to the Ethereum protocol last minute. The other ones, I think, are a lot more involved and do require quite a bit of effort. One other thing I'll mention that was talked about on the call is that developers said if EIP 7702, the one that Vitalik proposed in replacement for EIP 3074, is approved, a lot of the work that went into preparing EIP 3074 is not going to be transferable. It's not going to be re-applicable to preparing EIP 7702. So that's another kind of new work that developers will have to do to prepare the Pectra upgrade. And I think developers are still trying to aim for Pectra going live sometime this year, though, again, I still maintain that it will probably happen sometime next year. So I think, I think one thing to note is that developers are extremely wary about including and creating any more complexity for the Pectra upgrade, unless there's significant support from consensus layer and execution layer client teams. And one final kind of note, final note I'll make also about the discussion around EIP 3074 in these last few minutes of the show is to keep watching and keep a careful eye on how governance works as developers move forward with EIP 7702. It's quite rare that protocol developers are aligned about a code change, aligned about making a decision for the Ethereum protocol, and at the last minute, after that decision has been made, a stakeholder group that isn't really part of the protocol developer group, say wallet developers and account abstraction developers, that somebody else comes in and says, look, I don't think this should happen, and that make protocol developers really reverse their decision and try and find a new path forward. Usually when there's really strong disagreement in a decentralized protocol, it can lead to a permanent chain split, because these blockchains that we're talking about, especially Ethereum, it's an open source, it's based on open source code. So anybody can look at that code and build their own version of Ethereum that they think is better, that they think has more features that are cooler and will, that will gain more users, whatever. And that's always a really important part of decentralized governance, that nobody controls how Ethereum works and how the Ethereum protocol operates, and everybody is free to make their own changes to it, make their own additions to it if they want, by creating their own version of it and forking the blockchain. And as I said earlier in this call, this did happen after the DAO hack. Ethereum Classic is a fork of the Ethereum blockchain. Technically, Ethereum Classic is the version of Ethereum that didn't agree with an upgrade. So they actually didn't hard fork. They didn't upgrade. They stayed stuck with the version of Ethereum that didn't include the solution to having users get their funds back from the DAO hack. There was a fork, a chain split when the merge happened because some users were not happy with Ethereum moving over to proof of stake. And these chain splits are likely going to continue to happen because Ethereum developers have quite an ambitious still development roadmap still to come. And all this to say, when we have an example of decentralized governance happening that doesn't result in a chain split, that actually results in Ethereum core developers working with and listening to the disagreements of other stakeholders and trying to move forward in a way that creates even more consensus, where protocol developers are happy with the compromise and all other stakeholders. You move forward with basically stronger consensus, stronger support from the entirety of the Ethereum ecosystem, with a path forward that looks different from before. It's a different EIP, but it still garners the support of not only protocol developers but other stakeholders. I think that's a really positive sign of decentralized governance actually working on Ethereum and not always having to result in permanent chain splits. So again, obviously still TBD on what developers are going to do if the details of EIP 7702 aren't worked out. Will they still keep EIP 3074 in, or will they take it out because they know that it's not something that all stakeholder groups in the Ethereum community are in support of, or will there be some other compromise? It's it's an example, a case study of Ethereum governance that I think is important to continue to watch. And so far, it does really appear that increased dialogue and discussion and cooperation is happening as a result of the fact that anybody can participate in Ethereum governance at any stage of the process and materially impact governance decisions. So, yeah. That's it for today's episode. I hope you enjoyed listening to the show, and more importantly, I hope that you learned something new about the Ethereum ecosystem, the Ethereum protocol. I am signing off today from the concrete jungle that is New York City. I'm glad to be back finally in New York, and I hope that you will join again for the next episode of Infinite Jungle. And until then, stay safe out there, everyone.